Continuing with our recursion um, lecture on recursion, functional recursion, as well as with tracing. Let's go to DNA to RNA tracing. So I'm looking at the recursive version of the DNA to RNA program. I've had it right in the beginning of the definition of the function. Well, print the same name except for the input. Everything else is in string. Okay, let's comment that one and see what it did. So you can enter any DNA sequence. DNA sequence, you're allowed to use letters A, C, G, T. So C, A, G, G, T translates to D, G, U, C, C, A. Let me run this with the print to trace how it runs. I'll give it the same sequence, CAGGT, and let's see what it does. You see several things going on. To invoke CAGGT, the first call, I'm first checking the C because that's the first thing that it checks. For C, it gives me G. Then AGGT is to be checked. A, and then GGT has to be checked. G, GT has to be checked. G, T has to be checked, which is length 1 string, and then you change it. That's how it runs. Okay, so this is tracing for our code. You can now draw something similar to this. All right, so make sure you are able to draw something similar to it. One more example. Okay, now all these functions we saw so far, star triangle, palindrome, DNA to RNA tracing, they were functional recursions. Let's look at bullseye. Bullseye was an structural recursion. So a bullseye consisted of a circle and an inner bullseye. You see? So this process that is going from outside to inside, this is called unfolding. For a structural recursion, what you do is unfold. Here is the entire bullseye. Bullseye with red outside, black inside, and red innermost. So it's only 3 bands, notice. The outer one, okay, is a circle. You return the circle, you fill it with color red, and then you invoke bullseye again with the primary and secondary colors interchanged. Earlier it was red outside, black inside. Now it's black inside, red outside. Notice the radius also has decreased. Instead of 3 bands, now you have 2 bands. So that, to construct that, you need to invoke circle again, the outer one, radius 680, return, fill it in black color, return, and call bullseye with 1 band, lowered radius, exchange your primary and secondary, and because it is only 1 band, all it does is invoke a circle, filled it with color, does not have any more bullseyes to invoke, and returns. Return, return. If you remember, what is this called? This is called sequence diagram. Okay, so unfolding here is a sequence diagram. Okay, whereas unfolding for a structure, for a functional recursion, is an activity diagram. Okay. All right. After that, let's look at the factorial tracing. So this is the factorial function. I have already included print factorial n, the tracing part. Notice only the input is not a string. So as the input changes, you will be able to see the input. Let's run it. I want to find factorial of 4. It's returning 4. Oh, sorry. I want to invoke the function factorial 4. For factorial 4 required factorial 3, required factorial 2, required factorial 1, which gave me 24. Okay. By the way, you can improve this, make it more sophisticated print statement so that you can see factorial 4 equals 4 times factorial 3 and so on. You can try all of these other ways of making your tracing more sophisticated. Okay, but this is as of now enough to draw an activity diagram like this. Okay,